All right, welcome in. This is best time to buy and sell stock. This is the first problem in the sliding window section. So we were just looking at two pointer. We're now looking at sliding window, which is actually very similar uh, style of solution. So as before, we're going to be looking at a solution where we have two pointers to an array, so two indexes that we're tracking, and we have to be smart about how we move those pointers around to solve the problem. But I just realized I have it closed. We'll read through it as usual, do a little diagramming, code through a solution, and then see if we can optimize a little bit. Should be a pretty straightforward problem, so let's get into it. Okay, so it says you are given an integer array prices, where prices at index I is the price of Neatcoin on the ith day. So they're going to rug pull us later. It's whatever. It's Neatcode's new cryptocurrency that they've released. But we may choose a single day to buy one Neatcoin, and then we can choose a different day in the future to sell said Neatcoin. So obviously, if we want to make profit, that means we need to buy at a low price and then sell at a high price. That's going to maximize our profit. And then they clarify that we want to, like I said, return the maximum profit you can achieve, and then we also may choose to not make any transactions. So if we just don't buy at all and we don't sell at all, we can say that the profit will be zero. So maybe the best solution, for example, if the price only goes down, just don't buy. That would be one option for us to take. Okay, so in this case, the first example, prices, gives us this array 10, 1, 5, 6, 7, 1, and the output is 6. So obviously, in this case, we can just sort of look at it and try some combinations, and it's pretty quick. And the optimal way to do this is to buy at 1, which is the lowest price early on, and then to sell at 7, which is a high price that occurs later. That gives us a profit of 6, and that is the highest possible profit we can make. Again, we'll dig into how we kind of know that or how we can figure that out programmatically, but clearly when you look at this one, it kind of makes sense, right? Okay, and then like I mentioned with the purely decreasing or non-increasing array here, 10, 8, 7, 5, 2, the output is 0, and this is because no matter how we buy and sell, the only thing that can happen is either we buy and sell the same day for a profit of 0, or we buy on one day and we lose money by selling on a future day. So in this case, the most profitable thing we can do is just to not buy at all, and the max profit would be 0 in that case. Okay, and then the constraints they give us, the length of that prices array will be between 1 and 100. The individual numbers themselves will be between 0 and 100. Not that these greatly impact our answer here. Positive prices make sense. If they were negative prices, I think nothing really changes per se. But also that kind of doesn't make sense for the real life analog. Anyways, so fairly straightforward task here. We just need to buy at a low price and make sure we can sell at a high price, and we want the difference between those to be as extreme as possible to maximize our profit. Okay, so let's talk about what we can do here. We got 10, 1, 5, 6, 7, 1. We'll diagram this out a little bit. Okay, so let's say that this is our array here. What we wanted, well, there's a couple ways we can approach this. I think we'll go over kind of the naive way first because it's pretty quick. If we need to pick any 2 days, what we can do is just to do a bunch of comparisons, right? We could say, well, maybe we do 10 minus 1, which is 9. Let's do 1 minus 10 because we sell on the day where it's 1, we buy on the day where it's 10. So this would be negative 9. We'll start, since we know that we can just not buy at all, we'll start by saying like our running maximum is 0 because that's always going to be an option. And if we encounter a profit that is greater than what we've seen so far, then we'll replace that, right? So 1 minus 10, negative 9, that's not going to replace the 0, so we'll keep going. 5 minus 10, negative 5 doesn't replace it, negative 4 doesn't replace it, negative 3, negative 9. So this obviously is one approach that we can take where we just do all of the possible comparisons. So in this case, we would get like a profit of 4 and replace the running max. And then we would get a profit of 5, replace the running max. get a profit of 6. And so this hopefully feels pretty straightforward as far as this being a solution. 0 doesn't replace it. 1 doesn't replace it. 2 doesn't replace it. -4 doesn't replace it. And eventually we would get through all of these comparisons. And then we would be done. And that obviously guarantees that we get the correct answer because we considered all of the possibilities, right? Now, in terms of time complexity, this is going to be an O of n squared solution because although we cut out some of the comparisons by just looking at, what happens after the red pointer, we still theoretically compare every element against every other element. So that's n times n, or n squared time complexity. So the question from here is, how can we improve that? So if we are coming from O of n squared time complexity, what we'd want is to move into like an O of n situation. So we just look through each element a constant number of times. Or maybe n log n. Now, n log n is sort of the domain of sorting. And in this case, it doesn't help for us to sort because the order of these elements is actually important to us, right? So sorting, not helpful because we actually need to know where these elements were in relation to each other to begin with. So how can we be a little bit smarter about how we do the comparisons here? Well, to begin with, so that first round of comparisons that we did, right, where we said, hey, 10 minus 1, for example, or 1 minus 10 was -9. In a scenario where we get a negative profit, that's like never going to contribute to, there's no possibility of that contributing to the running max, right? And what I mean by this is if those are the two numbers we're looking at, and we get something negative, there's no way there's no way to keep the red pointer here and improve the answer. So whether the numbers go up or down from here, it's always going to be better for us to just move this guy over, right? So if you get a negative current profit, that's always going to be a scenario where we want to move the red pointer over by 1, right? And I'm saying the red pointer in our code, we'll call this like the left pointer. Okay, so 1 minus 10 is -9. We definitely don't want that to be our answer, but that also means that any future considerations that we want to make, they don't need to start here. They should start here instead, because that means we have like a lower buying price, which means more opportunity for profit, and we love more opportunity for profit. Okay, so that's like, I think one quick optimization we can make that dramatically improves it is anytime we get a negative, we just slide this guy over, and then we kind of continue from where we left off. We could add extra logic to say like, oh, if they're in the same place, then automatically move the right pointer over. But we can also just let that loop kind of resolve itself because this is going to be a profit of 0, and then the right pointer just moves over. Okay, so let's actually play that out just with that one optimization. So anytime we get a negative profit, we'll move the left pointer over. And anytime we get a 0 or higher profit, we'll move the right pointer over. Okay, so when we start this, negative profit, 1 minus 10, right? Slide this guy over, 0 profit, so we slide this guy over. Now we have a profit of 4, profit of 5, profit of 6, and then we get a profit of 0, and that actually means that we've gotten the answer. This one, I thought it was actually going to be more like difficult than that, but that's all we really need. Now, how do we know that this is the best answer so far? Because if there was ever a scenario where we had a decrease, we would have moved this guy over and had a better like buying price, right? But that didn't happen in this case. Let me think about how we can change these numbers to like make this more like interesting or more illustrative of the fact that this is like a good solution. I guess we just need more decreases, huh? Maybe we'll do like 10, 4, well, actually, I don't know if I'm being super smart about this, but let's change around the numbers and try it again, just to illustrate the point. And then we'll actually tackle the code because the code is pretty straightforward. Okay, so Is it already there? Oh, no, I think I got rid of the 6-7. Was there a 6-7 before? Because I totally missed that. Yeah, sorry guys. I missed the opportunity for funny joke. Okay, so let's take a look. So in this case, when we start, again, the scenario we're looking at is that we have a negative profit, which means we definitely don't want to keep the 10, right? We'll slide this guy over, and now that they're in the same place, there's a profit of 0, which means we can slide this guy over. Now, once again, this comparison gives us a current profit of -3. That's never going to be helpful for us. We know that the red pointer is not in the ideal place. We move it over. Again, 0 profit when they're in the same place. And then we get a profit of 7 here. Profit of 6 here. And then a profit of 0 here. So notice in the middle, in fact, I should have diagrammed this as we went. This is the first time right here that we get a profit that we should keep, right? So this is the first time we want to overwrite. In future iterations of this, when we move the right pointer over only, we are going to get, shall we say, good profits, but we don't need to, we can just track that by figuring out, hey, is the profit better than the running maximum so far? And this is going to ensure that we kind of always keep the red pointer in the ideal place. If there was ever a scenario where there was a decrease, we would catch that. So actually, let me, again, I don't think I chose the best illustration here. Maybe let's change this to a 3. And then change this to a 2. Okay. All right, so once again, negative, slide this over. 0, slide this over. Negative, slide this over. 0, slide this over. Okay, so we get a profit of 5 right here. Okay, and then since we got a positive profit, or a positive current profit, we move over. And this is the next time that we get a decreasing comparison, right? So since the current profit is negative, that tells us that 3 is not the ideal place for us to keep that pointer. And we can slide this over. Once again, we make this comparison and we get a negative number, which means we can slide it over again. And this, I hope, illustrates a little bit better that red pointer, by nature of the algorithm we're using, is always going to be in the ideal place to make a profit, right? So if we encounter a negative profit, that kind of gives us the shape of the data. It lets us say, okay, since I know that there's a decrease later, I can move that over. And as you can tell, by doing this, we don't have to compare each. So is there a place where the red pointer could be in the wrong place? There could be. And we can actually detect if it's in the wrong place if we have a negative profit. That's going to tell us, oh, there's a decrease, there's a better place for us to buy, so to speak. And we always check that before moving the right pointer over, right? So if we get a negative profit, we actually know that the red pointer is in the wrong place, and on every loop, we'll continue to move it over until we get it in a good spot, so to speak. I wish, I should have come up with an example before this that is, more illustrative of this. Yes, but if we only get a negative profit at the end, we would miss out on positive profit. So if we only ended up getting negative profits the whole time, well, one, we would always get negatives and zeros, and in that scenario, we actually do want 0 to be the max profit, right? So by nature, if we're always checking for the negative profit, and if there is a negative profit, we move the left pointer over, we're never going to replace the running max until we get, well, and I don't have this illustrated right now, but if the running max starts at 0, we're never going to replace it until we encounter a scenario where there is positive profit, right? If we got positives up until the last one, so if that was the case, well, let me think about it actually. So if we got all positives, in that case, that means that the lowest value, so let's actually illustrate this. Let's say it's 1, 2, 3, 4, 5, 6. Our left pointer starts at the beginning, right? Our right pointer starts right over. If we always get positive profits, we're only ever going to move, or positive or 0 profits, I should say, we're only ever going to move this pointer over, right? And that actually is what we want, because we want the left pointer to be at the minimum possible place, right? Let me clarify that actually. We want the left pointer to be at the minimum possible place, while still keeping the right pointer to the right of it, right? Or on top of it, because that's a profit of 0. If we do that, we're always guaranteeing that we're looking at higher profits that are to the right, or like higher prices that are to the right, while also keeping the red at the minimum possible value we can. So if the last number ends up being a 1, let's actually track that out real quick. Ooh, that's not what I wanted there. In that case, we start here, right? Profit of 1, profit of 2, profit of 3, profit of 4, profit of 5. This is going to be a profit of 0, but we're not going to replace the running max, right? So it starts as 1, 2, 3, 4, 5. When we get to 1 and 1, that's a 0 profit, which is kind of fine by us, actually. We're still guaranteed that 1 is the best place to buy right now, right? Because the profit is 0, or the current profit between 1 and 1 is 0. So we're still guaranteed that the 1 on the left is the best place to buy. We could treat this kind of, well, yeah, let me actually not confuse this too much. We'll go over it at the end. Now, let's say this was 0, because I think that's maybe the point that you're trying to illustrate is like, what if it gets worse? This is fine, because when we get here, we're going to get a negative profit, negative profit, negative profit, negative profit, negative profit, negative profit. And at this point, it's a 0 profit. And then the loop ends because this guy goes out of range, right? So the core idea here and the important concept is that we need to, like, we can detect better places to buy by seeing if the current profit is negative, right? That's going to guarantee that the red pointer stays in a good place to buy, or the best place to buy is what I should say. And it also guarantees that we're only looking at places to the right. Yes, so we could have sold at 5 instead of a profit of 0, and we detect that as we go, right? So when we start, or every time we do one of these loops, one thing that we are going to check is this the best place that we could sell, right? Like, what's the current profit that we would make if we were looking at these 2 days? So what we're tracking over on the right here is what's the profit if we sold right now, right? If we bought here and if we sold here. So profit of 1, profit of 2, profit of 3, profit of 4. So actually, I've got this listed wrong, huh? Anyways, profit of 4 right here is where you would stop in terms of the answer. We would consider this, but it's a negative profit, and only after that would this start moving over. Oh, and you know what? Actually, I was incorrect. Or no, yeah. Because if we buy at 5 and we sell at 0, that's actually a negative profit, right? So that's not something that we're going to record. But on the way there, we are going to record it. So hopefully that's clarifying that we actually are tracking the maximum as we go. The question is just like, how do we update the pointers so that we're always getting the best possible answer for like that buying and selling day? So yeah, we will track like the middle iterations, like in the loop. Yeah, exactly. So obviously, like, if we've had a really good profit, that's a profit that we want to consider that we can make. And notice we don't have to actually return the days that we sold them on, although it would be pretty easy to record that as well. But yeah, the running max is just like, if we encounter a profit that's better than anything we've seen before, we'll keep that number. We won't delete it, we'll keep it. And then the pointers moving just says, like, let's consider another day now. And notice when we do this, all good. When we do this, we don't have to compare everything against everything else. We just move these 2 pointers through like once, basically. So this is going to be like a 2n solution, which again, in terms of time complexity, we don't really care about that constant. And in fact, let's think about this a little bit though, because we are, well, let's actually test out the motion here a little bit. So they start here. We're going to move this over, and we're comparing every time, right? And then this. So actually, yeah, no, that's 2n. That's 2n. I was second guessing myself, thinking that might be n squared time complexity, but it's just everything moves through once. for both pointers. And that's at like the worst case scenario. There's actually, like if there was a, again, if this was like purely increasing, like there wasn't a 0 at the end, then I think it becomes really obvious that it's O of n, because we literally just look through everything once and then we're done. Like if it's always increasing, it just go, 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 and then we're done. Again, the nice thing is we don't have to make extra comparisons to figure out if the red pointer is in the ideal spot. We're guaranteed that it is as long as we move it over anytime there's negative profit. Okay, really long explanation, that which I think is good actually for this one because the code is really simple. But let's give it a shot. So we have our running max, which I'll initialize to 0 because again, it's possible that we just don't buy at all. So if we can't beat 0, let's just return 0. Okay, and then we'll have our left and our right pointer. Now, I'll say that these are going to be, left is going to start at 0, and right is going to start at whatever left plus 1 is. Okay, and then, again, as we do this, we know that we're not going to move the right pointer unless we have a 0 or positive profit. So the only thing we care about for the loop condition is that right should be less than the length of nums so that we don't get like an out of range error here. Okay, and now if we have a negative profit, so if prices right is, well, here, we'll say it this way. If prices right, which is where we sell, minus prices left, which is where we buy, if that's less than 0, then we will move left over by 1 because we know that this isn't the best place to buy, right? Okay, and if it's 0 or more, then we'll just move right over by 1. And I think that's it. Oh, you know what I forgot to check, which is actually, I realized this because I looked at chat and I was like, are we missing anything? The thing that we're missing is what we were just talking about, which is we'll capture the maximum between what we've currently got recorded and, well, this. I guess it would be better to, so again, in terms of code cleanliness, we can say current profit is prices right. That's kind of, that feels like a good drag name. Price, you could probably make a good drag name out of that. Minus prices left, okay, and then that, and then so this way we just aren't repeating that calculation, right? It's more descriptive, it's more expressive, makes more sense to actually put it in a variable here, even if it's marginally less performant. We don't really care. It's just a variable. Okay, anybody want to criticize me before I run this? Anything that you think we can do better? Or that I've done wrong, perhaps? Okay, sweet. We're going to give it a run. Let's see. Oh, okay. This is fine. This is just, these get initialized. I don't know actually how it, I can just change this to 1 because I know that left was 0. But I think we could also do this on 2 separate lines and it would work, but we'll just do it that way. Okay, and not nums, prices. Conceptually, it worked. It was just the names. So let's make sure she worked. Yay! Yeah, apparently the first time I did this, I did not understand the problem, but here we are. Okay, and that's what I got for y'all. Again, pretty straightforward problem in terms of the code. I think it's just like the assurance that it really is the best solution is something you have to chew on a little bit. And again, the whole shtick here is we have a form of detection on the best buy price that doesn't require us to compare against everything else in the array. We can just track it as we go, and we're assured that we have the best possible buy price so far. And we just let that play out until we're done. Show the last line. Oh, the last line is just the return statement, which is returning this thing that we've been tracking as we go, right? So again, that starts at 0. If we only saw negatives, then it never gets beaten. We just return 0. And if we found something greater than 0, it gets replaced, and that's the number that we return at the end. Do you guys want to see my bad solution? I wonder what my bad solution was. Oh. I almost wish I could, like, I almost wish I had time to dissect why this is wrong. That would be kind of fun. Maybe we'll do that in the future if we have extra time. But we'll call it there. Does anybody have any more questions that I can answer? Or explain or anything like that? This better be a good question, Mince. This better be a good question. Oh, he stopped typing. Okay, we'll go ahead and call it there. And if anybody has more questions, please let me know. I am around and available. Oh, 2 people typing. Aw, no, happy to help. That's what we're here for. And if you, yeah, if you have more questions, well, okay, just as we wrap up here, would love to see y'all drop a solution in the text thread, which I'll provide a link to here. Yeah, no worries. Yeah, happy to explain. That's what we're here for. Text thread's there. Now you understand the problem, so give it a shot yourself. Post your solution in there. If you have more questions, we're there to help, you know. But we'll call it there for tonight, and I'll answer Mince's question off the clock, I guess, because he keeps typing and stopping. So good night, y'all, and I'll see you Monday.